Anyways, welcome out. Really glad to have you here, participate in our chain. I've been a tech enthusiast for a majority of my life. When I was young, my dad had like a business and we had to start sweeping walks when we were young, and then you graduate and you did accounting work, and then you worked the floor and stuff like that, and I hated repetitious work and stuff like that, and that's part of why I'm excited in kind of a collective work with peer-to-peer networks and trying to improve kind of the elite infrastructure that a lot of the banking institutions, stuff like that has. And so I was very excited to get involved in this. Bitcoin actually didn't really impressed me that much when it came out, but what they're trying to do in recent years has become more interesting and stuff like that. The problem is we want to decentralize stuff, but then we always end up centralizing things again. So the power doesn't shift and whatever. And so part of what I want to do is encourage people. You don't have to be a genius. You don't have to like grow up with computers, but you do have to take an interest and start working. Whether it's on a weekend or an evening or a night, or take some classes, whether Coursera or Udemy or university, or talk with friends. I remember the person at college that introduced me first to Linux, and that was kind of my love of Linux and kind of what was going on. But we want to encourage everyone to do your own infrastructure if you can. A lot of people are using the cloud and stuff like that for node validators, and that is an easy way. It's a good way to get startup running quick, low barrier of entry, but ultimately we want a distributed network. We don't just want it in a few data centers or regions across the world that are controlled by 5 or 10 big corporations. We want nodes all over and stuff like that. That's something that's made Netflix very successful, where they have not just in data centers, but they have distribution points everywhere in pretty much every neighborhood and stuff like that. And that's an impressive thing with peer-to-peer networks. You can start running a node at your house in your basement. Preferably through your government. Local industry, encourage high internet speeds and get involved in that. Where I live in America, there was a big push for bandwidth, and it has fueled a lot of industry and stuff in there. So anyways. Real quick, kind of goals, right? As any of you that have ever worked with the CISSP certification, confidentiality, integrity, and availability. That's kind of your goal of your node, or any software you run, or any service. That's kind of what you want to do. You want it's nice to have proper scaling architecture. Sometimes what you can do on one, like your PC or one server, it gets difficult to scale as you try and move out to 2 or 5 or 10 or 20 or 100. And a lot of modern cloud compute has been possible by automation techniques that aren't, it's not like amazing, like out of this world. It's just kind of very common sense things. Software is important. What you use is important to kind of read around, whether on blogs or magazines or stuff like that, and ask around. Reddit's a great resource. Hacker News. Use commercial community software. It works. Now most of them have both, so you can start using either free or open software, and then mix to commercial services as you need them. I always like this. Are we better than what we are replacing? Just some conversations and stuff. As I've been in the industry, a lot of times, I sometimes think we're trying to replace this infrastructure of people, and sometimes we just become what we want to replace, everything we're frustrated with a broken system. But I like this quote of Nietzsche, beware that when fighting monsters, you yourself do not become a monster, for when you gaze long into the abyss gazes also into you. And I've always liked that quote since I first heard it, because it's very real. We try and improve things, or we hate things and we prove it, but in politics and tech, it's all this. A lot of it's the same. We end up becoming as bad as what we were trying to replace. Or as my brother that's in the medical field, today's solutions are tomorrow's problems. But hopefully we can think ahead and try not to get those. And this quote from John Adams, why must we know and understand infotech? This is kind of part of my infrastructure. A lot of people want an easy solution to this, but if we don't understand the technology, whether it's blockchain or cryptography or the infrastructure it rides, we will still be at the mercy of whoever controls that infrastructure. And so I like this quote of John Adams, a U.S. politician. There's a great HBO series on him, but he's like, I must study politics and war, and I just added in infotech, code, blockchain, info systems, that my sons may have liberty to study mathematics and philosophy. My sons ought to study mathematics and philosophy, geography, natural history, naval architecture, navigation, commerce, and I put infotech in there now just to kind of apply it to today's time. I mean, this is 300 years ago and stuff, 200 plus years ago, and so infotech and agriculture, in order to give their children a right to study painting, poetry, music, architecture, statuary, tapestry, and porcelain. Obviously stated, but it remains true. Please reach out, regardless of what gender you are, regardless of whether you're going to university, but try and study. And this isn't just for here in this room. Most of you are probably quite versed in tech, but this is for others out there that don't think they can learn, but there's great resources. I always pop the ISC2 Code of Ethics, trying to have a higher level. I know a lot of times in the blockchain world and cryptocurrency and cryptography, people have a tendency, you get a lot of scammers and stuff in the group, a lot of kind of sales and marketing, a lot of trying glam, and but I don't like that. And try and be transparent and true in what you do. It's something that I believe in. And like I said, back to that Nietzsche quote, if we don't do that, we become just as bad as the other people that try and manipulate others and the system for their own personal gain and don't really add value to others. So this is, anyone that's interested, kind of some simple certifications in Linux and network security that I like. Hypervisors or virtualization. When you're running your own infrastructure, most of you have probably heard of VMware. I'm surprised how much with the cloud services over the last decade that people haven't used VMware. VMware used to rule pretty much everything. Linux, obviously with KVM, they introduced that in the Linux kernel, QEMU. That took over. You guys are probably aware of this year that AWS used to use Xen, Citrix Xen, Hypervisor. They are switching, or at least using the majority, starting to shift over to KVM. Kind of a big announcement. They kind of had their own modified hypervisor through Xen. But the cool thing, that's built in the Linux kernel, and it's available to everyone. So you can build high-end compute with open source software. And it's not limited. This is how AWS made all their money, was open source. That's really all they did. And then put some glueware, some glam, and yeah. One that a lot of people haven't heard of, it's a group out of Austria, is Proxmox. They used to do like spam filtering stuff, but they have a really good UI, and like most open source, it still is a little hard to get used to, but I say it kind of gives you the VMware feel with and functionality without some of the overhead that VMware, and it uses just KVM, QEMU, and LXC for any of you guys that have used Linux containers. Virt Manager, a lot of you probably use that with Linux. It's kind of the GUI thing. You can use virsh and the libvirt API and stuff like that. Containerization, just kind of listed there. Obviously, most of you are probably familiar with Docker. If you're not, use it. I hadn't used it a lot until I started doing a lot of development work and stuff like that. It can be very handy in continuous integration and deployment for tracking things down. So, anyways, orchestration, obviously, some of you old school, Mesos kind of used to rule. Now Kubernetes has kind of taken over. Docker Swarm, if you're using Docker, that's kind of came into place. Some of you that worked in large compute environments might have used Puppet or Chef. There's a million kind of orchestration suites out there. Like I said, a lot kind of mixed into Kubernetes. We're going to kind of cover just really brief. If you haven't used SaltStack, Ansible is another popular one too. The reason I like SaltStack, or you could use Puppet, Chef, I like SaltStack a little bit better, maybe because it's written in Python. It's kind of straightforward, been around for a while. But it is, and it's very easy to learn, but I like, it's just very simple and stuff like that. So I'm going to jump in and we'll run through some commands, and I'll try and get through this and some monitoring. I like to field questions, kind of just have an open question answer. Last time I did a presentation, we didn't have much time in the end. I like to leave at least half of it open. So just to kind of show you how easy it is, we'll jump into a little handy-dandy demo network here. And so what I'm going to do is I'm going to So the way it works is kind of like with most things, it's using asymmetrical key encryption, public-private keys. So you see here I have like 3 boxes. In my lab network, I put up a couple Proxmox, a couple VM hosts, KVM, right? We got kind of a simple NAS box and stuff like that. I can... I can go here. So let's just do a really simple run command here. Type right. Right, kind of really basic. You can see that it does a ls on the root, right? You could look in whatever, right? We could look in temp. We could do a host name change. We could do whatever you want, right? It's pretty easy to run commands. One of the gentlemen there, if you've used like Ansible and playbooks and stuff like that, Salt has kind of the same thing where you have, you can see how simple it is. And if you just type SaltStack getting you started in 10 minutes on the web, I've got it in my slide links later on, you can easily jump on and get that. But it's a little harder at first, maybe because you want to just spin up that one node and start doing commands locally. But try and just use like a centralized command server, whatever you want to call it. When I used to build kind of my own using Bash and stuff, I would just call it like Commander or whatever. And that's where Puppet, if you're familiar with that, where obviously the Puppet Master, for any of you Metallica fans out there, where that can kind of control things. But you see how it has packages. They have different kind of structure to install stuff. So we could run let's go. Apply. I'm very. Right, and these could do different things. They could do security patches. Obviously, like with the command, you could, you see on here, if there were updates, it tells you if it's failed. That kind of has an output you can kind of work with. They have, like everything, they have an enterprise offering that you can, in the cloud, that you, if you don't want to manage your own. Again, I always suggest work with the command line, work with how they work under the hood, and maybe build something for it, or again, just understand and use it. So anyways, that's an easy way. And you could apply that. You could update packages or install packages from not only one, right, you know, in this case 3, but it could be 3,000. So if you're running a bunch of databases, whether it's MySQL, Postgres, or Mongo, or whatever, you can do large changes. And obviously you could do kernel tweaking as well by running different commands like sysctl, pipe stuff into files, or reboot a bunch of boxes. And so you can kind of do orchestration through that. But that's kind of what I just want to kind of get used to that. And then let's jump back to the slides. That's kind of salt stack. I just want to kind of, if a lot of people, we have a big range of people. Some are used to that, some aren't. I highly suggest you look it out, check it out. And like I said, there's multiple options. There's a lot these days, so that's kind of that. Next step, we kind of get into monitoring. I'll get in a little more hardware and stuff after this. I wanted to kind of chew through some kind of software stuff. Some of you are probably familiar. These are kind of some more popular open source. A lot of you guys have probably heard Nagios, or Nagios, however you want to say it. Never been a big fan of it, but it has the agent on it. I'll give it that. Has been really good. Written in C, very fast. A lot of places use it, but these are kind of ones that I've liked over the last decade and stuff like that. And they have different already managed engines, commercial, but Xenos, Python built. It's not as performant. That's kind of why I like Zabbix. It's a little more performant and stuff like that. You can massively scale with it, and it's fairly efficient on hardware and stuff like that. So anybody that's used the Bro monitor too, obviously you have a different IDS and security things, but I'm going to focus on just Zabbix here. Like I said, a lot of telcos will use that. Again, you end up with easily with tens of thousands, even hundreds of thousands of items that you're trying to track. And if you have something that isn't very performant, you have to spend a lot of money on hardware and also software licensing if it's commercial in order to make it run. And again, the core of Zabbix is written in C and very fast. And a lot of people hate monitoring systems, but they are what they are. They're, everyone, it's just like coding. People have this idea that coding can be easy, and it kind of can, but not if you're doing much with it, right? It gets fairly complicated quick. So I have a little here on my repo, and I'll put all this stuff later for grab, but on my repo on GitHub, which is, it's pretty anemic and stuff like that. Most of the stuff I did in the past was internal, and again, I'm more of a systems-y, network architecture type of guy, and so some of my code might not look the greatest, but it is, I try and keep the logic tight and what it does tight. But this is just a good example of you can go in and replace your domain. So most systems, let's say you have work with domains, right? Search domains, and so like with Salt, I didn't show you, I'll do an install on that, but you literally just apt install if you're using Debian, Salt master for your master node, and then if they're all in the same search domain, by default, if you do apt install Salt minion, it will install on it will install and try and it will send your key to the salt master, and that's how hard it gets to add another. And then you'll go in and you'll list your keys here with the salt key command, -L or default will do it. It lists keys. I already just accepted them here before. You'll do that to accept them if there's keys in there, and then you can start running commands. And so it's very easy. But again, what it's doing at its core is it's just using private public key encryption. So it sends you the public key, so it's able to compute. And using the agent, this is where Ansible and stuff falls down, where Ansible, and SaltStack has this too, where it can use SSH and connect, whether it's a network router or whether it's a Linux box. But the nice thing about having an agent is if you have it nested 2 firewalls down or multiple NAT, it can still send that request out and back to the IP address. And again, it's using key. You have to accept the key before it allows any communication. But that's the advantage, whether it's with Zabbix. Zabbix will call it active monitoring versus passive, where it will send requests from wherever you want. And so in some small environments, it doesn't matter. I can connect to the port. It's always open. But if I have 1,000 nodes spread out that could be firewalled or not, it gets a little hard to manage those. And there's advantages to using both, and there's a place, but having the option of agents and being able to send stuff out from things that are behind NAT or firewalls is extremely convenient. So, yeah, so we'll jump in kind of real simple interface here. You'll usually have, this is so screens, you can create screens. I'll show you, so pretty much anything. A lot of you probably went to performance testing using Grafana, Prometheus. Again, whether it's SNMP, which I'm more used to that in the world, obviously SNMP and kind of Prometheus exposure, still the 2 top nodes, but you'll have screens like this, and you can zone in on time, schedules and stuff like that. There's not a whole lot going on this, right? Just kind of a test network. But you can go in and you can see how you have a dashboard here where you can easily group things up, and you can do permissions on groups and stuff like that. With that little script I sent you, when it will automatically configure the Zabbix agent, right? So apt install Zabbix-agent, it will install that, and then that, if you run it, it will go in and make the proper changes to the config file, depending on your domain, so use that domain, and then it will automatically connect if your setup is right. I think it's set up for Zabbix-monitor or something like that, kind of for default. So whatever that IP goes to, as long as that's accessible from that node, wherever it is in the world or on your private network, it will send a request, and then it will kind of auto add in. And you can kind of create templates and groups. So you see in here where there's kind of templates for different things. So let's just do the Linux. All right, so we can have some Linux here, right? So it will by default have these different items. Anyone is this, so you have quite a few stuff. There's a bunch, there's an open community that you can add a bunch of other ones. Obviously you have items that it's monitoring. Those items doing different things, whether it's CPU or memory or I/O, can knock off triggers. Those triggers will then, just like a gun, it will trigger an event or an action to do. And And one thing that people aren't very familiar with is with, is anybody here familiar with PagerDuty, or has anyone used that? Never? Okay. Adam is, anyone else? Yeah. I've always just kind of built my own relay, not very hard to use. You can use a lot of like Gmail or other services like that. A lot of them will throttle, but usually if you're under like 1,000 or 2,000 emails, you can, a day or like that, you can just use those to relay off, do SMTP off. Whether it's Zabbix or any monitoring system will support that, or even your little Python script that's running stuff. Oh, what's that? Oh, is that so? A lot of people don't know about email, though. Has anybody here ever used email to text before, where your telephone carrier, whoever that is, I have not ran into anyone, any carrier in any country that won't convert your phone number to text. So you can set up with these things, and people will try and sell you these services. Or there's Nexmo or like Twilio in the US. I think they're pretty much all over. You can use their stuff too, but most carriers will automatically convert your phone number. They'll have like a my phone number, whatever that is, at AT&T.net or T-Mobile or Deutsche Telekom or whatever, British Telecom. They'll always have something like that. And because most doing network monitoring on your node or whatever, you're probably, if you're like me, I kind of ignore email for a while, but text I'm usually responsive. But always look up your carrier. I'll have a link in here that kind of gives an example, at least for a bunch of US companies and stuff like that, that it kind of shows. But I know one of our guys from Czech Republic, he hadn't heard about it, and he just called up I think he went to their website. I don't think he even had to call in, but they're just like, yeah, put this in and stuff like that. So, so that's kind of that. Let's jump in. I was going to show you a little on just like Proxmox, so how it works. So on that, I was just kind of moving a disk back and forth. So any of you guys that are familiar with NetApp or storage disk, it is very useful. Most like whether VMware or Proxmox or KVM, a lot of them in order to do live migrations, which live migration, as opposed to not live, right, you'd be bringing hosts down, right? So with like ESXi with VMware, that would be free, but if you want to support that commercially, use that as an add-on. But most of them you'll need to have a shared storage server and stuff like that. But it's very easy to set up. Anybody here work with ZFS much and stuff like that? We got a guy back here. If you have not worked with ZFS, please, when you get home, either tonight or after the conference, use it. A lot of very large providers are using that. Ceph is kind of the other big thing. If some of you guys are familiar with GlusterFS, or but that's kind of a bunch of people, including Red Hat, Cisco, and stuff, where they're working on a clustered file system, right? So you can have multi-nodes all over. If some of you guys are into like ZFS, you might have heard of like Lizard or MooseFS that people are kind of working on. But Ceph is kind of the better open source for clustered management, node file system management. But ZFS, if you're just working on if you're not having multi-node, it's a great thing. And I just want to show you here how easy it is. So I just have this like NAS1 little demo set up here. And in this box, I have literally just put in like 4 drives, went to, you can go to Newegg or Amazon or Alibaba or whatever you want, and just order you some disks, or go to your local electronics store. And so here I just created, if we go literally, and I don't want to run it again, but I created, and I have some NVMe disks. We'll talk about this a little bit later. If any of you guys haven't used NVMe, please do use it. Kind of the evolution of solid-state disk is moving towards NVMe. And NVMe used to be used more for caching and stuff, but it's shifting and started being more used for disks, and it's highly optimized for. But anyways, you guys can see this command. This is as easy as it is. If any of you work like with MDM admin or stuff like that, or LVM, VG groups, this is as easy as it gets to create a mirror of 2 drives. You literally, or I'll actually go to the slide here. Let's jump. Let's jump down here. Through. Yeah, there's PagerDuty. Hardware is cheap. These are just some different places you can go. Servers direct, I mean, there's a million all over. Hardware is powerful. Evo's Samsung's 970 just came out. I should update that. This shows you kind of the different disk, and yeah, it's getting better. Solid state used to wear out faster, and a lot of optimization techniques, especially like ZFS and stuff used, would burn it out. But here's as easy as ZFS gets, right? So I throw my disk in. Right, so I'm just going to do a fdisk-l. You guys can look through here. Oh, there's SD, SDA. You can look at obviously you can look at dev2, this NVMe. Oh, that's picking up my Samsung Evo disks, or you could do Pro or whatever. We'll go into warranty on disk too, because that is important when running a node. But it's as easy as that. You can set compression on creation, or you can set it later. So in this case, so usually I create like different pools. So this one I just have fast and slow, right? Your NVMe. So if I have some, let's say I have a database that I'm cranking a lot of stuff on, or on the node, right? My LMDB, and I want 2 mirrored drives, right? You always want redundant, you want parity, and you want redundant, because drives do fail, most common failure. But you can see here, that's a simple RAID mirror between 2 drives. You can see the one below it is, if any of you are familiar with RAID 10, I just have 2 stripe drives. I could remove those mirrors on the bottom one, and it would become a RAID 0 array. So if I just want to crank some really fast stuff. I don't care if a drive goes out and I lose all my data. I'm just doing some performance testing and stuff like that. You're probably familiar with some of the performance testing that they did today. On that one, I don't care about that stuff. So I'm going to put it on RAID 0 and stuff like that, and let them go as fast as they want, right? Anyways, that's as easy as it is to do that. You can turn compression on. A lot of times you'll get like 1.5 improvement or whatever. So it's not on here, but let's do Z pool status. You can see how easy it is to look for errors here, right? You could script this into your salt commands. I guarantee you they already have states that are already made that you can go out and collect that stuff. You can use Zabbix for this too. We aren't going to have time for it, but you can easily pull in, you can just add like a script into Zabbix and have it pulled in. I was hoping we'd have time for that, but we won't. We'll try and get some, if the community and the co-op members and stuff are interested, we definitely can do some systems team, some peer programming. If you guys want to do it, say, hey, Jeremy or Meta or Kelly, I want to do a group, and I will help you set up your own infrastructure, whether it's a half a day or even a day, and we can crank out stuff if anybody's interested. I feel it's of value because, again, I want everyone to become a node operator all the way down to the hardware level, because that is the better way to, if you want decentralized, right? Or just put everything in the cloud, right? They're trustworthy, right? They might be, they might not, but I'm a fan of education is the only way to protect freedom. Anyways, yeah, but those are kind of the basic commands. Obviously, you have zpool IO stat, right? If you're looking at, let's say you have, obviously there's nothing going on here, but if you had like, I guess you could fire up Bonnie or whatever, but you could see stuff going, and then what was using up disk process and stuff like that. You could kill processes as well. I guess we'll show you how to get, just if you want to list git compression, and what do we call it, HDD? Oh, fast, that's what it is. So let's try again. Slow. Oh, gotcha. I grabbed off the end. Oh, that'll do it. Yeah, so you can see it's on. If you turn it on here, so let's just turn it on so you can see. On fast. A lot of people are like, can I do it live? The nice thing with ZFS, you pretty much can do anything live, right? Which is very convenient. We'll turn it on slow too, because we like that. There's pretty much no reason to not use it. It will use up a little more RAM sometimes, but it's... So now we can do ZFS get. Compression. Right? Yeah. And it will show you your value. I think it's -V or something. Anyways, it will once it starts kicking on, it will show you the what savings you're getting. You can always turn it off too. Anyways, I'm going to open the rest for like Q&A. A shout out to Suricata if you're doing IDS, Suricata or Snort. Yeah. Anyways, I'll open the rest for questions and stuff like that. If it doesn't have, and I can go on, we can get into firewalls and stuff like that if you guys are interested. Yeah. Yeah, maybe speak louder, kind of into it. It's an add-on. So if it's ZFS, utils, every system will be a little different. Most systems now, so like it is licensed, so it was Sun Microsystems and now Sun. There's an open source version of it, again, so it keeps in that realm. But it's not installed by default on most operating systems. You have to add it on extra. So that is a little harder. Like Proxmox or stuff like that will auto. You can just select it when you install. Just when it comes, it will by default ext4, but you just go more options and like advanced options, then add it, and then you can do your. So it's easy if you have like let's say you have a 2U or 3. Let's say you have a 3U chassis of whatever, 18 disks or whatever. You can easily just install it, add all your disks to that, and then go. But a lot of times you'll just install ext4 on the root file system. Let's say you have 2 drives, and you'll just install ext4 on those, do a mirror, and then you'll install your stuff running all your virtual machines and stuff like that. You'll create the RAID array there. But Proxmox by default will install it out of the box, which is another cool thing. So again, they've done a great job out of there on making kind of open source stuff a little easier. Yeah, it's literally just apt. It's like ZFS utils. You always can go DigitalOcean. I'm kind of a fan. They probably do the best of anything using ZFS. how to configure encrypted. Well, that's an encrypted ZFS pool, which you could do, but any of these. But it's going to be apt install ZFS utility, something like that. Oh, that's NFS. Which if you haven't used NFS, same thing. Yeah, ZFS util is Linux, is what it is there. So, yeah, you bet. Some are, some aren't. They'll have your commercial, probably, it's in my slides, like the Intel, it's a little more expensive, but they'll have their 4500 series like that. But you get into the thousands on that. You could run a node with them in and just make sure your whole machine's battery back. So if you did have a power outage, you could just shut down the node. That might be like a cheaper way of doing it. That's probably how I would do it if I was trying to cost save. Don't lose power. Just do a battery store where that's, you don't got to go to Tesla wall. You can buy your own batteries. YouTube has a lot of how-tos. But the NVMe uses PCIe, right, for its connection, where your old SSDs would use SATA and stuff like that. And it's optimized for PCIe. There's some articles there where it will explain to you, I can't remember if it's Network World or whatever, but if you look up articles on why, it's a little harder to find them, but why NVMe is better, it will explain the advantages, the way they're writing the blocks and stuff like that. And so SSDs aren't going away, just like spindle will still be around. But if you aren't doing large, like usually if you aren't dealing in video or something like that, it's more advantageous to use like the Evo, and I'm doing Samsung. In my mind, they've always been a little ahead of the group. They're a little, for your price performance, they're a little better. I have, if you want to type up Samsung warranty, SSD warranty, you can get a good list of, hey, what's going to be my failure rate? We'll tell you a good idea of what you should expect for failure is going to be the warranty on them. No, probably might fail sooner, but if it fails and it's under warranty, you can send it back in and they'll send you a new one. But the cheaper stuff that's consumer grade is obviously going to fail faster. It's usually half as expensive but it's going to fail twice as fast, a lot of it. But yeah, most of the new stuff, NVMe, if you were doing, again, unless you need large, massive amounts of data, which most people just need fast data, use SSDs. You can get like a 2U24 bay and put a bunch of 860s or Western Digital or Intel or whatever of just the SATA type. You can do that for slower, but again, you're not optimizing what it's set at. The NVMe are a little more expensive, but they'll come down in time. And so, yeah. But read that. I'll try and get examples of that to show the benefits, because you'll get in kind of shouting matches. SSDs used to not be very good. There's different types like TLC and MLC, and then now you probably hear like 3D NAND flash and stuff like that. That does mean something and stuff. And so, but the key is look at the warranty. There's always, like the Evo is their consumer grade. You're going to replace it more. It's cheaper. But sometimes doing it, if you're willing to do the operational stuff, sometimes it makes sense, especially if your startup costs you want to keep lower. Hey, I might have to replace this in a couple years, but I don't want double costs on my hardware and stuff. And then I can see, hey, maybe I don't like being a node operator, having my own hardware, and I want to do it in the cloud, and you have less, you lose less than half. You have half a loss versus your full cost. So I kind of like doing that when I recommend like a node. If you're just kind of dipping your toes in and getting used to stuff, go with the cheaper stuff, and then you can upgrade as you need it. You can monitor for failures and stuff like that. Some people used to actually, with the SSDs, they would, because it does have a limit, they used to like put one in and then wait for multiple days and put another one in, so they wouldn't, the chances of them failing close to the same time were less. But those are kind of other kind of strange things that you can do. But yeah, PCIe SSD, Spindle's going to be around for a long time, but it is slow, especially if you have to do backups and stuff like that. And I think as validators, I believe that node performance, they'll be king, the ones that can go more. That's my opinion. But any other questions or? Um, 10 more minutes. Does anybody here do much like firewalls or intrusion detection systems? Anyone go to the security that yesterday that Charles put on? Did anyone here go to that? He showed how you could DOS. You went there? Yeah. So he showed how you can DDoS a system, right? As you have more nodes, bandwidth kind of rules, right? And this is why, like Google or AWS, sorry I always bring them up, but that's why I know there's a billion others, right? Large, but they just want the fatter the pipe you can have, the less chance. Like people, if they don't have enough bandwidth to drop you, you're going to win the game, right? So that's why it's important for those large hosting providers to keep those bandwidths. Now you can write rules to detect certain anomalies, and you probably saw how he did, like Google, their kind of protection. It looked to me like AWS was like doing a BGP path switch and stuff like that. He explained about BGP, using that to change and do scrubbing, where basically if you're doing BGP, whether that's at your home or at your business, again, you have to work with your carrier and advertising that, but you basically say, okay, it's going this way, and I'm going to advertise BGP and have it take a different path to come to me, and then that will go through like a security scrubber or whatever like that. The problem, as he explained in there, is that they can see your IP address still. They can see where your range are. If any of you are familiar with Tor network, that kind of tries to anonymize IP addresses and stuff like that. You can set up as a poor man's like F5, if any of you guys use with that, or Big IP as it was known back in the day for their load balancer. You can use Nginx, has gotten quite powerful. OpenResty is a project that uses Lua, if any of you guys have used that. Lua is just, it's kind of an embedded scripted language. It's used a lot like with F5s and stuff like that. I think TCL is also used in some of those. But Lua is kind of turned dominant. But you can use, OpenResty is a Nginx with Lua mixed in it, and you can basically do packet mingling and stuff like that. If you aren't familiar with reverse proxies, look into them. We'll have to see. In the future, you probably can front your nodes. We'll probably have to do a write-up where you could actually use Nginx and do some smart filtering and stuff like that, and proxy it with that. There always are overhead and costs and risks to that, but let's jump in. Let's see. Here, I'll jump in real quick. Just so you kind of get an idea. pfSense is built on BSD. Any BSD users out here? Anybody use it? Yeah, a little bit. Yeah, Linux is kind of dominated, but BSD still has a heavy presence, especially in the network world. There's a good site on BSD tuning. The Linux kernel used to kind of struggle with network packets. They've done a lot of rewrites and fixes. Calomel, BSD, something like this. Let's see. Yeah, calml.org. These guys are pretty good because back in the day it was always, I really want to, I want to make packets go very fast, right? I don't have the money for a Juniper router or stuff like that, but I want packets to go very fast. And CalML had some pretty good write-ups where they were trying to tune BSD kernel and stuff like that and get those. But yeah, so I mentioned that. But pfSense is a firewall system. You can see it kind of doing here. This is just one front of my little demo lab at home. But you can kind of see, it's very easy to set up. It has like just basic rules like NAT. It has services like DHCP. If you're used to split DNS, it has a DNS resolver where you can add other hosts and stuff in there. Let's go into assignments here. You can, if you're used to VLAN tagging and stuff like that, it's a very clean and simplistic interface. You can do stuff by CLI as well. Linux is probably as performant. It might even be more now. Like I said, in the last 4 years, they've kind of cleaned up some issues. And so you can probably run stuff just as fast, but yeah, if you've used OpenVPN before, you can do IPsec, layer 2 tunneling protocols, and stuff like that. It sets up CARP really easy to do HA, so you can do load balance. Let's say you have 2 carriers. Let's say at my home I have 2 carriers, whatever. Unfortunately, in America, it seems like it's Comcast or CenturyLink. There's very dominant. I could have 2 carriers, though. If one carrier went down, I could swing the traffic and have it come up, have my node come up on another carrier. This supports that where you add rules in there. You can do BGP, like we mentioned before, with advertisements with your carrier. Let's go in. You can do, it supports like LDAP and different authentication mechanisms like that if you want centralized authentication. Like I said, you got your leases. We'll do diagnostics. They have a nice little package manager here where you can add on different things. So you see here where I have Suricata. You can go to firewall. Right down there, Suricata. You can add snort in. So it's disabled right now, but if we wanted to add snort in, it's as easy as, let's say you want an IDS. It is as easy as apt install snort or apt install Suricata on Linux as well, and you can script stuff out to do commands. But here, let's go. Have a really good community. Oh, I didn't go into why you would want to move. You're always on infrastructure, you're always moving stuff off one thing. This is why HA and clustering becomes important because you're moving stuff off one thing, upgrading the software on it, and then moving stuff back, and then upgrade the other node, the software that's running your virtualization machine or your firewall. You're always in this continuous churn. So it's important to use clustering or HA setup and stuff like that. But yeah, so that just shows, and then you can go to services. We got snort here. You can see where you have logs and stuff like that. But you can just add your interface, WAN, save. So it should fire up, but anyways. Yeah, let's restart it there. So anyways, that kind of in a nutshell is what I got. Again, encourage everyone, do your own nodes. Remember the Nietzsche quote. We don't want to just have a group of a bunch of non-technical people and a very tiny bit of people doing the code and the blockchain and the infrastructure and all that. That doesn't work. It doesn't. That's been my big frustration in most in business and stuff like that. You end up with all this non-technical and you have a handful of people. We need more people. Please, if you haven't, we're always open to new people. Apply. We always need new coders, new systems people. Always reach out to our chain and stuff like that. It's kind of hard to get in. Like they're pretty strict, but even if you aren't with our chain on that, use the bounty system and contribute through other methods and be a node validator and stuff like that. But anyways, thanks for your time. Enjoy the rest of the time here. So thank you.